Hello class, here we are beginning the review for the final exam. This is part 4, and I am going to examine question 61 using technology, which I'm requesting that you possibly try to rent the calculator from the library. I believe they do have rentals, but I would hurry because of the exams. Or get yourself a TI-8384, borrow one from someone. Someone has to have a TI-8384. And this will make your life really easy to manage with this example. So notice that I'm using integer 2. That makes a big difference. And let's see what we have here. So this is going to evaluate, it's going to first integrate the question, and then it's going to evaluate each of the values from 3 to 1. If you notice, your answer is already prepared for you. It's 36. The equation where you have from 2x to the third, and you subtract the two areas, you end up with 40. The second part of the equation where you have the negative 6x to the negative 2, this ends up giving you a 4. Obviously 40 from minus 4 gives us 36, and we have our answer. And so that's what I would recommend. Try that. Or in essence, you take the antiderivative of 2x to the third minus 6x to the negative 2, and then you just evaluate it at 3 and 1. Okay, here's question 62. We have to evaluate this in the interval E1, and you have 10 over x dx. So remember, this is basically, once you take the antiderivative, in essence, this is, let me do this step by step. So we're going to first find the antiderivative. So we know that this is 10 natural log of x, and if x in this case happens to be I believe it's 10 or 1, so you end up with x 10 times the natural log of 10, absolute value of x plus c, and you're substituting in the two extreme values. So 10 natural log of 1 plus 10 natural log of e, and you end up with natural log of 10 over e as a final answer. So for 62, once you're done differentiating it, the answer, because the natural logs always cancel, will be just 10. Natural log and e, natural base e always cancel. I have another example I'm going to share with you because I think it's important you understand that we're looking at the antiderivative of the value b minus the antiderivative of the value a. And so when we look at the integrand, remember this is b, this is a. So let me give you a couple more examples just to warm you up with this topic, since it's fairly new to you. This is 35 to 5, and we're looking at 3 over x dx as an example. And so I know that when I take the antiderivative, this f of x value generically would simply be 3 natural log of the absolute value of x plus c. So if I take the first value, 35, this will be 3 natural log absolute value of 35, and then that minus 3 natural log absolute value of just the 5. This will just be the 5, and then plus c, of course. Make this a little bit more visually appealing. You can throw it into your calculator and you can solve for this respectively, and I believe this becomes 3 natural log of the absolute value of 35 over 5, which results in 3 natural log 7, which you can evaluate obviously in your calculator. Let me give you one more just in case. If I have another integrand, let's say I have, and I'm looking for the area from 8 to 4 of 7 over x dx, I want you to remember once again that the antiderivative in this case is simply 7 natural log absolute value of x plus c. And once again, we're looking at b minus a, so 7 absolute value of natural log of 8 minus 7 absolute value of natural log 4. And so this becomes 7 natural log of 8 over 4, which would become 7 natural log of 2. And you can evaluate it as well, just like that. Okay. So that is 61, 62, and a few examples. Let's take a look at 63. So number 63 is another area problem. So it says a population of bacteria grows at a rate where we have P of t is equal to 12 e to the t, and if we take the antiderivative, we already know that it's basically going to be the same thing. So if I substitute in the values for the area, and I'm looking for the values from t is 3 to 0, I'm simply going to do 12 e to the 0, 12 e to the 3. So 12 e to the 3 minus 12 e to the 0, this will yield you 241 and change. There's a few decimals, but they're small, minus 12, which comes to approximately 229. And that's all you have to do for number 63. Number 64 is equally as easy. On this example, you have to look very carefully at the graph that they give you. And so when you look at the graph, they are marking 1, 2, 3. So this would be 1, 2, 3. And at 3, we have, well, here's our graph. It looks like it's extending something like this. And so our graph goes from here to the origin. So there's also like at the origin. So when we look at the interval, we're looking at from 3 to 0 as a value of some function f of x dx. So you have to look very carefully at the graph. I do not like the graph in particular because it's kind of hard to see. When I first looked at it, I had to double take on it. Number 65, more of the same. We're given a graph. It goes by ones. So I will have 1, 2, 3, 4, 5, 6, and so on. So here's 1 and 2. At about 1, this starts to come up as such. And when you look at your graph, you could see very clearly that between 1 and 2 is the area we're taking, and it says that y is equal to g of x. So that means that this is 2, this is 1 of g of x dx. That's as easy as pi. I can't explain how much easier that can be. At 66, it says find the area bounded by f of x is equal to x squared minus 4x minus 5 and y equal to x plus 1. So this one takes a little bit of work. Let me find. Okay, so the first thing I did to find the area bounded is you set them equal to each other. So x squared minus 4x minus 5 equal to x plus 1. Basically set them equal to each other. Subtracting x plus 1 on both sides. So that becomes minus x minus 1. My apologies. Minus x minus 1. And so we end up with x squared minus 5x minus 6 equals 0. These both cancel. You factor them. We factor them. Notice I'm going to use x minus 6, x plus 1, both equal to 0. Means that the 2 points, or the 2 edges I'm going to look at, are 6 and negative 1. So if I take the area, it's going to be equivalent to 6 negative 1 of f of x minus g of x, obviously dx. So if we employ this process, we're going to get x squared minus 4x minus 5, and then this is minus g of x, which is x plus 1. I think I put a double negative there by accident. So minus g of x. If we're looking at the area between 6 and negative 1, that is the essence of my question right there. Remember, this becomes negative x minus 1. So I'll end up with x squared plus 5x minus 6 again. Either use the TI 8384, or we could do this by parts if you wish. Doing this on the calculator one more time, I'll show you real quick what it will look like. So I'm going to go to math. I'm going to go to number 9. This is integer 1, so negative 1. You have to be careful. If you put subtraction, it'll mark you wrong right off the bat. This value here is now you have x squared minus 5x minus 6. And of course dx. It's approximately negative 57.16 repeating. And if you do this via reducing and actually substituting, you're going to end up with 343 over 6, which is equivalent to 57.16 repeating. So remember, you just simply subtract or substitute in both. So if I substituted in the 6, this is 6 squared plus 5 times 6 minus 6 minus, again, this would be negative 1 squared plus 5 times negative 1 minus 6. Once done, you will have 343 over 6. But I apologize for this. 1 second. I'm having a brain fart. You actually need to take the antiderivative. I'm thinking of something else. So let's find the antiderivative. So we have x squared, originally 5x, and then minus 6. And we're going to remember to add 1 to the exponent and divide by 2 plus 1. This is 5x to the 1 plus 1 divided by 1 plus 1. And this is technically 6x to the 0, so plus 1 divided by 1. Whoosh. Cannot believe I did that. So here's x cubed over 3 plus 5x squared over 2, technically minus 6 plus 1. Excuse me, minus 6x plus c. What's wrong with me? I've been doing this all morning long. You have to understand this is my 4th hour recording. Okay, so we start with again, we're integrating from 6 to negative 1. It's in the calculator that you put in the original function. The calculator does it for you. So this becomes 6 cubed over 3 plus 5 times 6 squared over 2 minus 6 times 6 minus, so this is just the first part of the equation. Now we're going to do negative 1 cubed over 3 plus 5 times negative 1 squared over 2 minus 6 times negative 1 plus c. Why am I putting, don't even need that. I mean, them dingbat moments. So yes, you can continue working from here, and your answer finally should be 363 over 6. Remember, you need a common denominator, hence why the 6. Notice 3, 2, and technically 1. Alright, just helping you with that. Okay, so that's just basic. 67. Let's look at number 67. Uh, 67 is the same thing. You're going to throw this into the calculator. You're basically going to take f of x equal to x squared ex and qx equal to 4 minus x squared. You're going to find the area to 3 decimal places bounded by this function. I used technology, so just throw it into the TI and go in that direction. You should get approximately 7.67. That's what I got with my calculator. Um, 68. Okay, as you look at number 68, this is another question that without technology is almost impossible to solve. So we're going to put in our bound, which is 1, lower bound, upper bound is 5, b is 5. And they're telling us that the function is e to the x, so e, I don't know why it just did that. Let's go back, 9. So again, 1, 5. This is again second e to the negative x. So I'm going to put integer x, negative x, and then come over to x. And about 0.36. About 0.36 should be your answer. Next question is 69. For 69, okay, on this question I was able to do this one by hand, so let me do it with you by hand. We use technology. And again, you can do these with a regular calculator, just have to do it step by step. For 69, it says the rate given to us of the rate of flow of a continuous income stream is given by Ft is equal to 1 over t plus 1. They want to find the total income produced in the first 30 days. So we're looking at t of 30. So if we find the antiderivative, you find that this is t over t plus 1 squared. And as I express this, this will be 30 and this will be 0, 30 days. So if I also look at it, I can also look at it as the natural log of t plus 1 instead of doing this part. That might not even be essential. And we're looking at it between, again, the values of 30 and 0. So we're looking at 1,000 times natural log of 31 minus 0. This gives us approximately 33.98 in the calculator, which I would consider 3434 as the final answer for you.